Hello and welcome back to Coded Universe. Today, we're exploring a key question in programming. What is an interface? What is an abstract class? And how do they differ? This topic might seem like a mouthful, but fear not. We'll break it down into digestible bites using real-world examples. In the grand scheme of object-oriented programming, both interfaces and abstract classes play pivotal roles, yet they serve different purposes and are used in different scenarios. So buckle up as we kickstart this exciting journey. Let's start with interfaces. Think of an interface as a contract or an agreement. It's a promise that certain methods or properties will be available for use. But here's the catch. An interface doesn't specify how these methods should work. It just assures they will be there. Intriguing, isn't it? Let's paint a clearer picture with a simple, relatable example. Imagine buying a new smartphone. When you purchase a phone, there's an implicit contract that it should perform certain functions. It should make calls, send messages, take photos, and allow you to browse the internet, among other things. Now, the way these functions operate, the user interface, the speed, the quality of photos, all these can vary widely from one phone to another. Yet, regardless of the model you choose, you know these basic functions will be there. That's the essence of an interface. It's like saying, hey, I don't care how you do it, but you've got to do these things for me. So, in programming terms, an interface sets a standard of what methods a class should have, but it leaves the details of how these methods are implemented up to the class itself. However, the way these functions are implemented can vary widely between different phone models. This is what makes each phone unique, and yet they all adhere to the same basic contract or interface. Now let's move on to abstract classes. Think of an abstract class as a half-built house. You're given the blueprint, the foundation is laid, the walls are up, but the rest is left unfinished. This is where your creativity comes in. Just like the house, an abstract class provides a basic structure for your code. It outlines the essential features that all objects of this type should have. But here's the catch. It leaves the details of these features for you to fill in. For instance, every house needs doors and windows. But what type of doors and windows? That's up to you. Imagine you're building a house with an abstract class as your blueprint. You've got the basic structure. It's a two-story house with a garage. But the plan doesn't specify what type of doors to use or how the interior should be designed. This is where your creativity comes in. You're free to choose the type of doors, the color of the walls, the style of the windows, the design of the interior. Everything that makes your house unique. This is the beauty of abstract classes. They provide a shared foundation, but they also give you the freedom to customize, to make your code your own, to build it just the way you want it. This allows for a shared foundation with the freedom to customize. When deciding between an interface and an abstract class, think about your needs. Both are tools in your programming toolbox, each with its own strengths and purposes. Picture an interface as a blueprint, a list of methods that a class must implement. It's like a contract that ensures a class provides certain functionality. There's no pre-existing code in an interface, just the promise of what a class can do. On the other hand, an abstract class is like a partially completed puzzle. It has some pieces already in place, providing a skeletal structure that you can build upon. It can define both methods and fields, allowing you to customize and extend its functionality. So in essence, an interface is all about the what a class must do, while an abstract class is about the how it might do it. If you need a strict guideline or contract without any default implementation, an interface is your go-to. But if you're looking for a partially laid out plan that you can build upon and customize, then an abstract class is what you need. And that's a wrap on our exploration of interfaces and abstract classes. We've demystified these key concepts, highlighting their differences and unique use cases. If you're still curious, don't worry, the world of programming is vast and ever-expanding, and we're here to guide you through it. So if you've enjoyed this journey, don't forget to smash that like button and drop your thoughts in the comments. Subscribe to Coded Universe for more insights into the coding cosmos. See you in the next video.